Even the most powerful microscopes struggle to get a glimpse of proteins. Scientists must use X-rays and sophisticated machines, along with a lot of computations, to determine what proteins look like. Deciphering the structure of a protein is a heavy lift, but it's worth it because the secret to how any protein works lies in its unique structure. When we zoom in on Pardaxin, we see that it resembles two twisted spiral staircases connected by a short loop, making a hairpin shape that resembles a bobby pin. Each of the spirals is known as a helix. Positive charges along the loops are attracted to negative charges on the surface of cells lining the inside of the shark's jaw and gills. When the Moses sole senses an approaching shark, it releases a milky cloud containing millions of Pardaxin molecules. Each protein becomes attracted to the shark's jaw and gills, much like a magnet jumps from your hand and onto a refrigerator. Once latched on, the Pardaxin molecules act like thousands of tiny thumbtacks, poking minuscule holes in the shark's cells and causing their insides to leak out as salty ocean water rushes in. The disruption of the cell membrane and the imbalance of salts within the shark's cells temporarily paralyze the predator, giving the Moses sole enough time to escape. Having a shark repellent at the ready has helped the Moses sole survive in the Red Sea for millennia. But Pardaxin is only one of thousands of proteins made by the fish, each with a specific structure and a precise function. Together, they make life at the bottom of the Red Sea possible. Proteins are not unique to the Moses sole. They are found in every organism, from bacteria to bananas, birds to bees, algae to alligators, and mold to chimpanzees. We make our own proteins and use them for almost everything we need to survive. Each one of our 40 trillion or so cells is packed full of proteins swimming shoulder to shoulder in a solution of salty water. In fact, proteins make up about half of the molecules in our cells. Most of the other half is water, and the tiny remaining percentage is comprised of DNA, sugars, and lipid, fat molecules. If one of our cells was the size of an average American home, it would be filled with about 30 billion proteins, ranging roughly from the size of a grape to that of a watermelon. Each of these proteins carries a story of who we are and where we come from, and not just our family history, but also our evolutionary history. That is, how we are linked with everything around us. Proteins convey our origin story, and potentially the origin story of life itself.